We're going to look at example 1 in your section 4.6 notes. So first up, we need to go through our definition for linear approximation. So our function is going to be approximately the linear approximation for x near the a value that you're given. So essentially, you're just writing the equation of a line when you write your linear approximation function. So remember, f of x and y are the same. So we're going to take y minus the y value of the point is f of a. Okay, and then that's equal to the slope. So the slope is the derivative at a, and then we're going to take x minus the x value of our point, which is a. Okay, so y and f of x essentially, like I said, the same. So our linear approximation is about the same as y. We just need to kick this over. So we have f of a plus the derivative of a times the quantity x minus a. So that's what we're going to use in part 1 when we write the linear approximation. Okay, so this is our function f of x this time. So we need to go run through our 3 steps to write the equation of a line. First part is to find the slope. That involves the derivative, which is going to use the quotient rule. So we're going to have x plus 1 quantity squared, squaring the denominator. Writing the denominator, the derivative of x, of course, is 1. Okay, and then we subtract x, and the derivative of the downstairs is 1. Okay, when we work this out, the x's will cancel, so we end up with 1 over the quantity x plus 1 squared. So our slope is going to be the derivative at our point A, which we're given as 1 for this problem. So over here, we're going to get 1 all over 1 plus 1, that quantity squared. So our slope is 1/4. Okay. All right, next up, we're ready for the point. So for our point, our x value was 1. Finding the y value, like we said earlier, y and f of x are the same. So I have 1 all over 1 plus 1, so our y value is 1/2. Okay, so ready for the equation, the linear approximation equation. Okay, so starting with this version, and then I'll replace y and f with L of x at the end. So I'm going to have y minus the y coordinate of 1/2 equal to the slope, which is 1/4, times x minus the x coordinate, which is 1. Okay, so replacing y with L of x, we get the linear approximation equation. Kicking that 1/2 over, we get 1/2 plus 1/4 times the quantity x minus 1. Okay, you could clean this up, but it's actually nice to leave it in this format for what we're going to be doing in part B. So we might as well just go ahead and leave it that way. Okay, so speaking of part B, we're trying to figure out what's happening with our function at 1.1. So we're going to plug in 1.1 to our linear approximation. So we know that f of 1.1 is approximately the linear approximation at 1.1. Okay, so we're going to end up with 1/2 plus 1/4 times 1.1 minus 1. Okay, working that out, we're going to have 1/2 plus 1/4, and then this is just going to be times 0.1. All right, and then that's something you can put in your calculator. When I went ahead and typed this in, I got 0.525 as my answer. Okay, since you're given the function, you can actually double check this, right? I mean, we could definitely find f of 1.1. We really don't need a linear approximation to do it. So I always check these. Okay, so if I plug in f of 1.1 into my function, I can get an exact answer for what this should be. So I'm going to have 1.1 all over 1.1 plus 1. And when I plug that into my calculator, I see that the exact answer is 0.524. And that gives me a good check of my work. So 0.525 is a little bit of an overestimate, but yeah, I know that I did it right, and that completes this example.